I'm Hongjun Choi from Purdue University. I'm going to present my paper, RVPLAYER, Robotic Vehicle Forensics by Replay with What-If Reasoning. This is joint work with my colleague Juan Chang and my advisor Xiangyu Zhang. So as we know, the robotic vehicles or autonomous vehicles are very popular these days, right? So they are used for various applications, including package delivery and passenger transportation, and the military drones, or the RVs for underwater and the space exploration. All these vehicles are safety critical, and any failure of this system can cause physical damage or the human, threaten humans' life. So, however, we have seen a lot of accidents of the autonomous vehicle for various reasons, such as the human factors like operators' mistake and erroneous control commands and unknown software, hardware glitches. Moreover, with the popularity of autonomous vehicles, the number of accidents will be increasing more and more. In this context, the after-attack investigation to analyze root cause of the accidents will be particularly important. So on the other hand, the incidents may be caused by cyber and physical attacks. Actually, Iran hijacked the US military drone RQ-170 in 2011, and hackers remotely controlled the vehicle by exploiting the vulnerability of the entertainment system in a car. Even worse, some vulnerabilities and attack tools for the commercial drones are already available on the internet. So the after attack or after accident investigation or forensics would be more challenging under such advanced cyber and physical attacks. So let me give you an example of advanced attack scenario to motivate our technique. This example illustrates the stealthy multi-stage and the long-time attack on a drone with the malicious parameter updates. So here is a drone, and the operator can issue multiple commands to update control inputs such as control parameters and missions at runtime. And given the planned trajectory for a long-time operation, let's say several days, the drone may encounter different types of physical disturbances. And while drone flies, the operator can issue benign parameter or missions, but the attacker also can pretend to the malicious, pretend to normal operator and issue the malicious parameter and updates. Here, the malicious parameter roll gain is responsible for the roll control. So the malicious large value 5.7 actually caused the misbehavior during the significant roll change. But during this moment, the mild turn or the straight flight, there is no significant impact because of this malicious update. So the attack actually hidden for a long time. And when this drone encounters some conditions like wind gust and sharp turn, they show some control errors and make some crash in this case. Okay. So in this scenario, it will be very challenging to identify root cause because this malicious update happens a long time before the actual crash. So because simple and naive investigation would determine that it is because of the wind gust and the sharp turn, and it determined that it's a natural accident. However, we know the actual root cause is the effect of malicious update maximized by the wind gust and the sharp turn. So the combination of these factors actually caused the accident. So to analyze the root cause, we need to investigate all the past cyber events, for example, several hundreds of the parameter updates, and physical change for a long time period. for example, time series of 6 degree of freedom or 12 degree of freedom at 400 Hertz. And various type of external disturbances, plus the combination, all the combination of these factors. So for efficient and effective analysis, we need to address several practical challenges. Challenge 1, so how to measure all these non-deterministic external disturbances. The vehicle may equip some large number of physical devices for the specific physical properties, but that is not practical solution. And the second, we need to maintain such heavy flight data for a long time period of time, and considering the resource constraint and in RV system. And lastly, to avoid manual investigation by the domain expert, we also need to support some systematic method to identify root cause of the attack based on the recorded logs. So we developed RVPLAYER, which is an efficient replay-based forensic framework on a drone to reproduce the accident and the reason about its causation. So here is an overview of our technique. It has two main components. First one is on-the-fly logging, and the second one is offline after accident analysis. So our on-the-fly logging is very efficient and innovative, which addresses the aforementioned challenge 1 and 2. And first, our disturbance observer inserted in the system leverages system's dynamics model and estimate aggregate effect of external disturbances without using any dedicated physical sensors. Second, our adaptive logging technique reduced log size significantly by selectively recording only the abnormal state information during flights and save a lot of the storage. In our experiment, it reduced log size by 90%. And based on these logs, so our offline analyzer systematically locate our root cause of the accident. So our replayer reproduced accident in simulation with the dynamics model, and during replay, it changed the configuration, such as cyber event and physical event with disturbances, external disturbances, and observed consequences to see which factors actually contribute to the accident. So let me explain the key idea of each component in the next slides. So as I mentioned before, the measuring and recording the different type of disturbances like wind, temperature, or the dynamics effects, and so on, requires a lot of dedicated and special type of physical sensors, and which is not practical. So we use disturbance observer to estimate the aggregate effect of the external forces without using dedicated sensors. It is very widely used method in the robust control methodology. So we can decouple and recording the external disturbances without physical sensors. Here is the example. So the drone tried to keep the balance by so in this case, the sum of the thrust of the bimotors and the gravitational force will be 0, right? Later, without the disturbance forces, the forces remain the same because we don't have the additional external forces. However, when we have a strong wind in this direction, the only the drone tried to keep the balance by increasing the thrust on the right motors. Otherwise, the drone will be tilted to the right. However, the model doesn't include any the external forces, and only the increased thrust is applied. So by measuring the physical state difference in acceleration, we can estimate and decouple the external forces. In this case, wind force. The wind force is separately recorded in the log, and we can apply it during the replay as one of the physical events. So another key feature is the adaptive logging. So considering runtime resource constraint in the RV system, we reduce log size by adjusting logging frequency at runtime based on the anomaly of the current physical state. So the key observation is that the normal operation, excluding disturbances, are mostly nominal and predictable and reproducible. So we don't need to record all the normal state. Instead, we record only abnormal state and disturbances with high frequency. In this case, as you can see, between the time T1 and T2, there's a big deviation between the normal and physical state and the model state. So for this period, we increase the logging frequency. So F logging frequency is determined by these equations, and intuitively, the frequency is adjusted based on the anomaly of the system. So this is very innovative, and because during offline replay, we can reproduce the missing nominal state by our model. So here, between T1 and T2, we directly obtain the abnormal state from our log, and the rest of the part will be regenerated by our model. So next, I will explain how to investigate the attack. In order to identify root cause, our technique performed the multiple replay with what-if reasoning. Here is a previous example. For each explanation, I will abstracted the cyber event to C and disturbances to D. So first, we do simple replay with the initial computation by applying all the factors in the logs. And then it will reproduce the original accident. Then, given the initial computation from the entire factors, we mutate it by randomly selecting some of them to disable during replay. And we can determine that the set of the disabled elements include the root cause if the accident is suppressed, but it could be the superset that include the other factors as well. So we keep searching to find the configuration that has a minimum number of disabled elements that can suppress the accidents. This process may require a lot of replay runs. So we utilize the meta-heuristic search algorithm, like a genetic algorithm. So the quality of individual during the selection process is measured by distance from the initial configuration and the upstream. So we extensively varied our technique with the various target system and various attacks. In total, we used 6 RVs, and besides drone and robots, we also used the 5 real-world the auto-driving attack traces to investigate attack. And we use real-world missions in urban area with diverse errors. Okay, performance. Our log reduction rate is over 90% with the adaptive logging technique for various missions and environments over our multiple targets. And we have also small runtime overhead, which is which is most 7% in our target system. It actually does not interfere with other tasks, and it can be easily accommodated in practice. And we also report some how accurately our technique generate the original trace. And the average position error of RVPLAYER is less than 0.7 meters across all target vehicle. And the figure on the right shows the comparison between the original physical trace and the replayed trace. And you can see the error between red and black line, very small, and compared with the baseline that has no disturbances. Okay, lastly, we also evaluate our technique with the various types of attacks. These attacks are all from the recent CPS security papers as shown below, and we tested a total of over 1,000 attack instances of various kinds, and RVPLAYER can accurately identify the root cause of the attacks. We additionally report detailed result on our paper and project webpage. In addition, we also report case studies with a variety of demo videos. So in conclusion, we introduced RVPLAYER, which is a novel forensic frameworks for RVs. It captures environment conditions, disturbances at runtime and replays to reconstruct actual attack traces. And our adaptive logging and what-if analysis allows to efficiently and effectively identify root cause of the accident. So thank you so much for your attention. I'm happy to take any questions. Yeah.
Thank you. Let's thank our speaker.